Hi, I'm Chad Slaughter. This is Hennrietta.
Hi.
We're going to talk today about bitemporal data and implementing it in Postgres. Why do you include time in your data models? So assume all you have databases. Who here has a database that does not have a date or a timestamp field in it? Anybody? No? Okay, so we have one person who doesn't have.
There's at least one that does not have.
I truly find that hard to believe. But, so we got one. We have one of many, but all of you have to deal with time, so.
I'll count how many I have on my laptop.
Good, thank you. We need better statistics. There's been a lot of research into temporal models throughout last 25, 30 years. And a lot of very smart people doing a lot of really smart things, including, it's actually now in the ISO SQL standard, there's a form of bitemporal tables included in that. And I say a form because we'll talk about that a bit. One of the things that all these smart people, problem that they have is the same problem of most of IT, which is a problem of terminology and overloaded words. While we're trying to implement this bitemporal model in Postgres, we kept, or at least I kept confusing myself by trying to use the standard terminology. These are some of the words that they've used over time: valid time, transaction, system time. And if you'll notice, most of those terms have 2, 3, or a dozen different meanings. Transaction time is, of course, my favorite because when you talk about a database and you talk about transaction time, what are you talking about? I guess you have the database transaction, you actually have an underlying I/O transaction, you have the system itself, you have the application. So it's like, what does transaction actually mean? And in the temporal model case, when they say transaction time, they're actually not talking about any of those. They're talking about a completely separate concept. So if you can have a conversation using the term transaction time in temporal modeling and not confuse yourself, you are a much smarter and better human being than me. So we actually use, Johnson and Weiss came up with 2 terms, assertive time and effective time, that we found to be the best terms that are relatively standard, been used before, and that don't get into these linguistic problems of trying to describe something unlike valid and transaction time. So, oops. So why do we actually, so everyone uses time, so you understand like, oh, we have to have some sort of time dimension, but why do we need 2 time dimensions? Sorry. The point of having 2 time dimensions is you have history of data. So you want to start tracking some sort of change to your system. So you put a timestamp on it. But now, what if you've recorded something, you want to correct it, right? So now you have this problem of, hey, I have this data which I've timestamped, but now actually I want to correct that data. How do I now note that for a period of time, in the database, we actually thought one thing, we had one value, but then we went back and we needed to correct it. So the best example I have is like financial data. You have financial data, you have a quarterly report. You run your quarterly report and outkick some values. You do an audit, you find out, whoops, we messed up some transactions, we didn't properly account for some things, so we need to go back and correct it. In most systems, you can't just go in and change that value and go like, oh wait, instead of a 3, that should have been a 4, and rerun the report. You need to actually record that, hey, this used to be a 3, we thought it was a 3, we executed our entire business on the fact that this was a 3, and now we're going back and saying, nope, we changed it. So you want some sort of audit. If your original data has a time dimension, then editing that data again requires another time dimension. That's the essence of bitemporal. So how do you capture these changes, not just for now, but also the past and the future? So we're not only making a change right now, we're potentially changing the future or we're changing the past. So my financial example is always, you're doing an audit, you find a problem, you may not actually want that that change to show up in the books until the next quarter. There's all sorts of financial reasons and perfectly legal reasons why you may want that data to show up in the next quarter. So now you found a problem. What are you going to do? Put it on a sticky note? Remember to type it in next quarter? No, you need to be able to enter that data now. And that's where the bitemporal comes into play. It allows you to do those type of things. Just the concept of having bad data. You have bad data, there's a time associated with it. How do I now track the changes to that data time over time? So you need a second time dimension. How do you insert data into your database such that it will only be visible into the future? This is where you need that second time dimension as well. So you want to insert data about what's happening in your business right now. My favorite example is, let's say you have two databases that have, or two order databases. So they have current data about present and past orders, and you want to merge them together into a single database. And you want this merge to happen instantaneously, and you want to be able to actually edit or audit your changes to know, did we actually copy the data in perfectly, right? How are you going to do that? Well, if you have bitemporal, this actually becomes very easy. The order date is one time dimension, and the assertive date becomes the second time dimension, which allows you to copy the data in and set an assertive date into the future. And when the time clicks over, then suddenly all your data that you've copied in becomes instantly visible to the system. But the second before, the data isn't visible. So now you can copy data in at your leisure, verify that it's all there without affecting a production system. Nor do you have to take a production outage, nor do you have to hurry up and do all these things at 3 o'clock in the morning. You can do them normal hours, normal time, when you're awake, and then have the system switch over automatically with no intervention. So, Hennrietta is now going to talk about the rest of these things.
Yeah. So now let's talk about practicalities, because we believe that going bitemporal is cool, but actually my goal now, our goal now, takeaway, which you guys will walk out of here, just be sure that that's what you need. Your database need it, your business need it, etc. So let me go into more details and explain of what exactly we are doing and how the bitemporal tables are different from everything else. So that is like schematic representation. We have here like very simple table of customers. So like the regular table would be customer number, customer name, and customer type. If we want to add time, meaning we want to keep the history of the customer, then we add the effective time interval. So that will be the same set of fields and plus the time when the specific values are effective. Now, in bitemporal, we are adding one more time interval, which is asserted. So that is the time interval when we asserted all the rest is correct. And again, I showed you this shiny schema, this shiny diagram, and you're still probably not sure what I'm talking about and why we need it and how it can be used. So now let's walk through the bitemporal operations, because each database operations, insert, update, delete, are executed a little bit differently in the bitemporal world. And moreover, we actually have to add more operations which do not exist in standard SQL. So bitemporal insert is actually the easy one because it's no difference than like the regular insert. So how we do, so let's say today's date here is May 1st, 2015. So we are adding a customer record, and we are saying this customer will be customer from June 1st, and so that's when this custom becomes effective, and that's the assertive interval. So assertive interval says that we believe, so we add this record on May 1st, and so from May 1st until whatever, we assert that this information is correct and true. Okay. Now, what happens with bitemporal update? And that is more interesting, because for normal update, you would just correct this record number 1, right? For temporal data, if you want to add new information, you will just add one more record. But in bitemporal world, we do it differently. So what we're doing, first of all, we change record number 1. So how we change it? We close the asserted interval. So now how we read this? That from May 1st to September 15th, so today is September 15th, we asserted that this customer type is silver for like forever. Now, on September 15th, we know that this like customer type was only effective from June 1st to September 15th. And now that's our current assertion. And then we are adding record number 3. And here we are saying that from September 15 to whatever, this customer will have type gold. Okay? So now we do not update, so we actually update one record and add 2 more. Cool. Now, what Chaja said about correcting mistakes. So now a week passed. Okay, so it's September 22nd. We're like, oh, shoot, actually, he shouldn't have been gold. He should have been platinum. And mind you, it's not like we want to put new information. He's platinum now. Now, we never should have put him as gold. We should have put him as platinum from the very beginning when we made this change. So now, what we're doing here, we are making another change, okay? So we are saying, so the first 2 records about silver, they remain unchanged. So we correct record number 3. And what we're saying, okay, so from September 15 to September 22nd, we asserted that this customer is gold. But on September 22nd, now we correct ourselves. And now we assert that this customer is platinum from September 15th. So we add 1 more record, and that is correction. That is bitemporal correction. So this way, as you can see, you can run reports like either way. You can like run reports how it should have been. You can run how these reports would run in this week when we had wrong data. So bottom line is we can run reports on both corrected data and or how we messed up. And we also have like complete audit trail out of this. Now about bitemporal delete and inactivation. That's actually something we added to the asserted versioning model because they all considered one type of deletion, and we realized we need to have 2. So the first one we call bitemporal inactivation. So what happens? So we thought we have this customer, now we're saying, no, actually he'll be gone on December 31st. And so what we are doing with these records. So that's what we had, so our record number 4. So today is November 5th, and that's when we realized that this customer will be terminated on December 31st. So now we are closing this assertion interval and are saying, okay, so we thought he will be effective from September 15th to infinity, but now we assert that after December 31st, he just won't be here. So that's his last effective date. Since December 31st, there will be no information about him. I mean, he will be customer, and we'll have this information. He won't be customer, but we'll have information that he used to be customer. He's not anymore. That's one situation. So that's like it becomes inactive. It like evaporates from current reports. Now, when they actually want to delete and still keep audit trail of, okay, we deleted it, but we still want to know that what it was here. So that's how we do it. We do bitemporal deletion. And you can guess now how we're doing bitemporal deletion, because that's about changing the asserted interval. So what we're doing now, okay, today is November 17th, and now we want to delete this customer for good. So what we're doing, we are closing asserted interval. So now, watch this. We do not have any asserted records after November 17th. So everything what happens after November 17th, we do not have this customer in the system. None of the reports which will be running as asserted now will have any information about this customer. However, if we wanted to go back in history and say, how did it look before that? We always can run reports based on the earlier asserted date. And again, we have complete audit trail. So now with these 5 records, we have actually total complete audit trail of what has been happening. Okay, any questions on that? Because I spent like half of my time on this because I just want to make sure that this is all clear, understandable. Any questions on how this works? Yep, 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 no? No questions, okay, all right.
But we need the effective date end as 12/31/2015. It'll be terminated after 11/17, right?
No, okay, so the question was whether this customer will be terminated after November 17th. No, it won't be terminated, so he's still terminated on December 31st. However, we have information that we want to delete this customer on September 17th. So basically what we're saying that after November 17th, we do not want to see this customer information. So it's not like how he was terminated. We do not want to see this information. He's like wiped off the system. Okay, okay, more questions?
What's the data type of that?
Oh, the date type, okay. So I will talk a little bit about this in a second. Actually, the beauty of this model is that you can put any date type, whatever you need for your particular project, for your particular task. Okay? Anything else? Nope. Okay, let's move on then. Okay, there will be more, I'm trying to save time for more questions at the end because we are going through lots of stuff. And like, again, as I said, my primary goal is to show why you might need it because it's super cool and gives you endless flexibility and endless options. Okay, now that was all about operations on the database. Now let's talk about bitemporal constraints. So database not only has like data, it also has constraints. And in bitemporal world, not only operations will be different, but constraints also will be different. So what are the constraints we need to implement? First of all, it's temporal integrity constraints. So this primary key and unique constraints, they will be different in bitemporal world. And temporal or bitemporal referential integrity, the foreign keys, they will be also very different in the bitemporal world. So we will talk about this in a little bit when we will just move to the implementation. Now, all this theory so far, it had nothing to do with Postgres, right? So we've been talking like for like almost 20 minutes so far, there was no mentioning of Postgres. So now there comes the cool part. Because as Chad mentioned, these researchers had been around actually for more than 20 years because I read about them in like mid-80s and that was not new. So like honestly, when he asked me whether I want to be a part of this, I said, I dreamed about this for 20 years and I would love to do this. And in Postgres, actually, with all the recent enhancement, it made it so easy. So there are two things which make this bitemporal support super easy in Postgres. First of all is the interval types. Again, even if you look at most of the works regarding the temporal bitemporal data, they all operate with two separate fields for each time interval, beginning and ending, and then all this talks about open-ended and close-ended, all this stuff. So with Postgres, with interval support, with any types interval support, it makes it easy because you do not need to implement it as a special type. And by the way, the other cool thing that Postgres has infinity. And again, in most of you guys who ever had to implement historical data where current is current, you would face this, or then the effective end date should be null, and then you have to write comparison separately for each of these cases. So in Postgres with intervals and with interval which can end with infinity, no brainer, cool. So this one is like very cool. And the other part which made it like super easy to support, just in the set. So that is how we actually define bitemporal table. It's exclude using gist. So here we show how this table of customers will be implemented in Postgres. And actually, there's one piece missing, but not important for now. So it's customer number, customer name, customer type, effective range, which is timestamp range, asserted range, row created at is like our internal timestamp, and gist index tells us that for each customer number, effective range and asserted range should not overlap. So like what this means, that you can have multiple effective ranges with the same asserted. You can have multiple asserted for the same range, but none of these can overlap. And if you think about this, it's pretty complex criteria, and the only thing you need now is just write this one statement. And you know what? What's the question?
When you specify here customer number, that is the primary key.
Oh, okay, I will talk about it in a second. It's a great question. And here, okay, the thing is that I will talk about constraints. There is difference here between primary key in the standard sense, like the primary key as a table.
It's the domain key.
Yeah,
so he's asking if customer number is the primary key.
Business key.
It's the domain business key for the data,
yeah.
yes.
Yeah.
But it's not the primary key.
Yeah.
Strictly speaking.
So it's not the primary key for the table, but it's primary key from business perspective. Okay. Yeah. So, like, honestly, when I first got this, I could not believe it covers all our needs. Like, I spent time evaluating, making sure I cannot, mess around with this, and yeah, that works perfectly. Okay. So that is an example of one of the tables we use for our tests. So here we have, we have the table Postgres cluster, which has all these time ranges, and it has the bitemporal constraints. So there's like foreign key constraint and unique constraint. And so there's one table which we use as a reference, and then we have Postgres cluster which references the previous table, and it uses the foreign constraints, and we will use this example in a little bit, like closer to the end of presentation, actually. So like one word about the time relationships. So in order to be able to implement all operations on time ranges, we have to implement Allen relationships. So what it is about? The Allen relationships describe all possible relationships between intervals. Some of them are implemented in Postgres. Some of them are not implemented precisely. Some of them are just named differently. So basically, for consistency of this project, we implemented and re-implemented all these relationships. So in our repo, you can see all these functions which are defined exactly precisely how they should be identified, how they should be defined with Allen relationship terminology. So we can, like, if anybody wants to know more, we can like address it at the end of the presentation. Now, defining the date ranges. So different tasks, different projects, different universes might require different time intervals with different precisions. So how we solve this problem? First thing, when you want to implement bitemporal model for your task, for your project, we define domain, which is called time period, and we define the time endpoint. And then all of our functions are using these domains, and then they are like compiled according to whatever is good for your particular project, for your particular task. Okay. And then I will go like kind of briskly through all the functions which we defined to support bitemporal model. Again, these functions are mostly proof of concept. So at this time, they are not meant to be super efficient, but our goal was to model all bitemporal functions, all bitemporal operations, the closest to standard SQL, because our final goal is kind of make these bitemporal tables the part of SQL, like kind of make them one other type of table, or even make it invisible. Like a table might be either regular table or bitemporal table, it should not matter. So first function is create a bitemporal table. Again, we try to make it as close as create as possible. So what it does, you actually pass the standard definition of create table here, and then That's it. And then you pass the business key. So the business key is something which would be your primary key if it would be a regular table. And then the function itself generates the bitemporal table based on this information. So if you look at the table we previously mentioned, database version, so that's what you pass to the function. And that's what it would like. And then it would generate the table definitions which we showed previously. Okay. The other useful function is to check whether the table is bitemporal, because technically speaking, you can manually create the table as bitemporal. So in this function, we just check that the gist index is in place and we have effective and asserted time ranges as a part of the definition. And that's enough to call table bitemporal. Then any other bitemporal operations can be used to communicate with this table. Okay. Now, those are just the illustrations of how you can execute these operations, which we reviewed in the beginning of the presentation, with our functions. So for bitemporal insert, so that was inserting this date, we call the function bitemporal insert. And this, like, as normal inserters can be, we pass the effective date and asserted date. For bitemporal correction, so same thing. So we pass the table name, we pass which field is changing or which set of fields is changing, how it is changed, then we pass the business key value and we pass time period. Actually, interesting thing here, I'm saying we pass the business key. Technically, it's not necessarily the business key, because when you write your update statement, you can put any criteria. You update records where, like, something is something. There may be multiples that might be not business keys. So basically, this condition is like, what is the update condition for this record? So each of these updates can update sets of records as normal update. And that's, again, the works on assertion model. They do not really stress this. So when we started to implement this, that we realized that everybody implies that you update one record, but the update statement, nobody told it will update one. It might update multiple. So our implementation covers this. The bitemporal update, so again, same thing as we just mentioned on the previous slides. Again, send the same information, but we just say that that is not correction, but update. So that's like a difference in the behavior of this function. So instead of bitemporal correction, it will do bitemporal update. So adding new information, not correcting the information which was wrongly put there on the first place. And then it's bitemporal inactivate. So it's again the separate function. You can refer to the previous slides. It does the same thing. And bitemporal delete also, like, just executes these operations which I described. Questions so far? Because I've been fast. Sorry.
I might have missed this because I had to step out and take a call, but I assume you had to add the btree gist extension to be able to generate those exclusion
Yes.
constraints?
He was asking if we had to add the
Yeah.
btree gist extension. Yes, we did.
Yeah. Mm-hmm. Yes, definitely. Yes. Yes, question?
You'll be talking about the performance.
You know what, we will be, though we do not have much data on this, so it's more in like our future work. So, but we'll talk a little bit at the end of the presentation, yeah. But that's one of the areas where we need more research.
He was asking about the performance work.
Yeah.
We'll talk about it later.
Okay, constraints, fun part. So how we define bitemporal constraints. What we need to define first? We need to define primary, unique, check, not as not null, and foreign key. So check constraints and null, not null, those are easy because those are the only two which are now different from the standard constraints. So no difference here. primary key. So primary key, you could already see in the definition in the bitemporal table how we define it. So primary key should be like business primary key and the effective asserted exclusion, so building just index with exclusion on these fields. And foreign key, it's totally different story. It's much more complex. So let's look at what are our supporting functions. First of all, when you define normal regular constraints on your Postgres table, so these constraints are written in the catalog, and when you run the command for this table, you can see all the constraints listed like under the definition. So we wanted to like have the same presentation, but our constraints are not in the Postgres catalog yet. So we were trying to do something which would mimic the like appearance of normal constraints, and will won't like do anything else basically. So all this meta code was developed for the presentation purposes only. So the way to describe the bitemporal constraints, we add check constraints, which are always true. So like the first part of this constraint indicates that it's like always always true. And that is true or something. And then the rest of the constraint text, it describes what is this constraint about. And we have the like rules how we code this contents of this constraint string, and then our functions are able to decode it and understand it. So for primary key, we have this like constraint with using gist, and that is like the essential part. We make sure that it is a primary key, and we also add the corresponding check constraints so that it will be visible when we describe the table. And the function to do this is pk constraint, and we can use it to define. Actually, interesting part here, so primary versus unique. Earlier I said that yeah, in order to define, to create the bitemporal table, you need to have this bitemporal primary key with effective asserted with exclusion. However, technically speaking, same as with all normal tables, primary key and unique constraints are like basically the same. It's whatever we define as the primary key. So I do not know how we will end up, what will be a requirement, but at this point we have a flexibility switching between unique and primary. So to define the unique constraint, we need to do exactly the same thing. So if we have more than one bitemporal unique fields in one table, so then we need to create additional index with exclusion, with effective and asserted. And the only difference is that when we define this constraint, we just say that it is unique constraint. That's it. And again, I think that there will be a room for flexibility. And so that's the function to create this constraint and to add it to the table. All right, so foreign keys. That is very interesting because yeah, it seems easy, right? So I mean, when I started this part, I did not think it will be like so super complex because okay, we have these gist indices, we have this exclusion on both sides. What's the problem? Actually, it is a problem because when you define the bitemporal foreign key, what you need to ensure? You need to ensure that all the values in the referencing table are effective and asserted at the same time as the values in the record, which we, in which we define this foreign key. And that's not an easy task, let me tell you. Like we tried like lots of different ways to implement this. So now we have like working prototype, which we believe it's true until proved otherwise. So we believe it's working correctly. And what we're doing here, so we need to define the foreign key constraint, and this only defines the check constraint. But then, after you declare this foreign key constraint, you need to actually define underlying piece of it. So yeah, be with me here. That is like the newest addition to our repo, add foreign key. So we are adding a foreign key to this table on this column, referencing this table and this column. And what happens inside? So first, as with normal foreign key, we are validating that the reference refers to primary or unique key. So first thing, we need to call this function and check whether in the referencing table we have this column as the primary or unique. Then we call this function which creates a check constraint to describe the foreign key constraint. So far, so good. Then we check whether there is a validation function on the foreign table. So, okay, be with me here. So each time we want to validate the foreign key, so we insert record, this record has a foreign key somewhere else, and we need to validate whether we can add this value or update to this value. So each time we need to go to this parent table and check whether this value we are going to insert exists within this range of effective and asserted. So to do this, we generate a validation function on the other table. And it might be when you add the new foreign key constraint, then you can find that this validation function already exists because there is some other reference to this key. So then we do not need to generate it. But if we need, then we call, first of all, we look up the validation function. Again, we have standards on how it should be named, so there will be like no mistake. And if not, then we generate this validation function. So this function, what it does inside, it generates the code and then it executes it. So this function is, put over the parent table, over the referencing table. Sorry, one more thing. So when it's all created, then we need to create triggers on insert and update on this field, which is the foreign key, and then each time we insert record, this trigger will fire. So now, after all this setup and the foreign constraint is created, so each time the new record is inserted or this field is updated, we run this validation function and we check whether the new value is consistent, so whether the referential integrity is preserved. And and only inserted when it's like works for all of the foreign keys if there are multiples. Any questions on the foreign key? Yes?
You said that need to be all exact. It's not like one table kind of overlaps with the referencing table. The temporal part need to be exact.
The question was whether the temporal part need to be exact. And the answer is no, it should overlap. So basically, like when you insert for some effective value, then we need to know that the matching value in the referencing table is effective like at this time. So it may be overlapping, but overlapping is actually easy. What is more interesting, there may be, for example, two different or more than two different intervals on the referencing table. So most important that all this time area should be covered. Okay, that's why it makes this task so complex, because it doesn't have to be exact. It would be easy, but that's not true. Okay. Any more questions on foreign? Nope. All right. So that's like basically this last two slides is literally like straight from the oven to the table. So we'll like just finish this piece. And again, I believe it works. We'll see. So you can see for yourself, actually. So that's the public repo. And it was it, did you merge? No. You did not. Oh, okay. Okay. So you won't see my.
I'll merge it after this.
Okay. So now, right as of now, you cannot see my bad deformatted code, like frantically completed in the past couple of days. But you will see it. So yeah, like everybody, welcome. Take a look and criticize and tell what we did wrong. Again, this is so far not about best performance. It's basically a proof of concept. And you have to wait till next time I will say the performance is not important. But that's the case when I'm saying at this point performance is not important if I work on a proof of concept. Yes?
So, question. So, effective dates range, right? So, is it always a single interval, or can you have multiple intervals?
Okay, effective range, is it always?
Repeat the question.
Is it all? No, can you repeat what's the question?
So, you have a date range, right?
Yes, that range.
Is it a single range, or can you have multiple ranges of effectiveness?
Okay, so is it always single range, or you can have multiple ranges of effectiveness? Yeah. So for each individual record, and in this case, I mean like physical record in the database, there is one effective interval. However, it behaves as is dictated by the conditions of the index with exclusion. So one record, when it will change, it will be new effective interval. So as we mentioned earlier, there may be multiple effective intervals for different assertive intervals, and there may be like the opposite, so several assertive intervals for one effective. So like in general, there will be multiples, that's what we expect, but there will be separate records for each of the intervals. Okay. Does it answer your question?
I think so.
Okay. Any more questions? So far? Yes?
For work, I implemented an application that uses concepts from the Snodgrass book, so I'm familiar with that book.
Okay. The question was like how this is related to a Snodgrass book, and
It's primarily based off this other book that's more recent, and I just wondered how it's different.
Actually, you know what? Probably we will like kind of finalize it, and then you can talk more about. So the question was how the like recent researches are different from Snodgrass. Actually, the authors say in preface that Snodgrass like blessed their work basically. So like I was raised on Snodgrass work, and I like happily accepted this new development. But Chad will talk more about this. And you want to go for future work?
Yeah.
Okay. So here comes our future work. And what else?
Yeah. So future work, what we're going to continue is complete the foreign key support that Hennrietta was talking about. Deploy this to production application. Right now, I'm using parts of this in an application managing X509 certificates, but don't have the foreign key stuff. So even though it's concept code, actually trying to get it into an application. Longer term is take the prototype, prove that it's working, this is the whole complexity of what we've been doing, is actually understanding the temporal logic, multiple dimensions, and being able to correctly reason about it. That's the whole point of this prototype and why we're trying to be so exact, so that when we know that that's working, we can then actually convert it to a C extension, use the Postgres catalog as it's meant to be, instead of hacking around with check constraints, and create types that just work. So instead of creating tables, you can just add a foreign key, a bitemporal foreign key, and have it actually just work without worrying about any of these things. So that's our longer term. In terms of performance, that's our main step, is because it's PL/PGSQL right now, so the performance is limited. Once we convert it to C, then we should actually have much better performance. The biggest performance issue is actually better indexing strategy. So the gist exclusion and doing the foreign key comparisons are going to be the largest bottleneck in terms of reasoning about the operations. Those are where our performance bottlenecks are going to be, of trying to figure out, hey, does this table have the records that we actually need, and things like that. So does that kind of answer your question about performance? So. And your question, Snodgrass. So the biggest extension to what Johnson and Weiss did as it relates to Snodgrass is one, partially it's the linguistic problem of changing the terminology to be clearer about what we're actually talking about. And the second was extending it into the future. So there's a lot of constraints in Snodgrass work in terms of pinning certain values to what's happening with the record. And what he doesn't actually talk about is, how do I deal with the future? How do I insert records? How do I insert information into the database that I know now, but that I don't want to show up until later? So the example I gave earlier, which was if I'm merging two databases in that have current data of orders, but I don't want them to all show up until a certain point into the future, the original temporal model stuff doesn't actually sort of address how do I deal with these future assertions where I'm inserting something, but I'm not going to insert it. I'm not going to assert that this is, live data until in the future. So while our examples, I should say, our examples here sort of are tying the assertion interval start time to the actual date. That's actually to simplify this so you understand this, but that date can actually be in the future. There's no constraint in terms of when we can actually start that. So that's where the differentiation starts happening.
Okay, yeah.
Does that answer your question? Sort of.
So I think my question is sort of related to this. Have you looked or thought at all about using RLS in 9.5?
Have we thought at all about using RLS?
Well, the row level security that's in 9.5 potentially could be used so that you'd filter out records based on a given date. So you could kind of take this, overlay RLS, and then you'd get a snapshot of the database as of a certain point in time.
No, we haven't thought about that. So the question was, have we thought about using RLS, which is in 9.5? No, to do this filtering.
But we do not need snapshot though, because the thing is that we need to query across the intervals.
Right. So we've sort of been talking about this idea that the data that we're looking at is what should be available now, but the power of bitemporal comes into the fact that you can actually write a query which says, what is my audit log? Well, you can take a query and you sort of say, my assertive and my effective interval is for now. So I want to look for records that assert for now. And that's what RLS would sort of, if you only wanted to look at now, it would allow you to filter that. But the real power is that with the same database, I can actually now write almost the exact same query, but by changing the effective and assertive times that I'm looking for, I can actually say, oh, give me everything that's effective now. So what that would actually, but that's only effective now, and then whatever assertive records. And so now what I end up with is I end up with actually a log file of all the changes of all my effective records. And all I've changed is one conditional on it. And so with RLS, I probably can't do that. So does that make sense?
I think with RLS you could.
I have no knowledge of it, so I'm not saying it can't do that, but I'm saying one of the reasons we're not looking at other things is because what we're trying to do with this data is that depending upon how you change the where conditions, changes the records that select, and those records, that selection has meaning beyond just the current snapshot. So I can look at history, or I can turn it around and say, what records will show up in the database in production soon, right? So I can actually now say, oh, show me all the records that have an effective date or an assertive date before now. So now I can actually look at records that will eventually be showing up in the future, or I can just look at the past, or what have you, or both. So, anyways.
Good, yeah. 1 minute,
Sorry.
last question here.
Any timeline of when are you going to be implementing that, like the C implementation?
We have no timeline on when we're going to. So the question was, what's our timeline? We have no timeline on implementing the C implementation. It's going to start after we've verified that our prototype is, when I say verified, I mean actually mathematically verified that it's actually correct. So.
Is the PLP just got really a performance bottleneck? Because the indexing is going to be
For the small application, so the question was, is PLP GSQL a bottleneck? For the small application that I'm using, no, I haven't noticed it. Indexing is going to override it. But when you're dealing with a much larger database, which is where we want to move this to, in terms of hundreds of millions and billions of rows, then it's naturally going to be. It's most likely going to be.
We do not know yet.
Right.
Yeah.
When we know it's triggers, you get two things. The server can override the query. So if you're doing a delete, sometimes it cuts down kind of messily, sometimes it'll do like a different kind of query.
Right.
So it has that capability. So you're not forcing the row.
Right.
So now
So.
Big room for future development.
Sorry, this time we can answer questions too afterwards.
Yeah.
Thank you.
Thank you.